Hello everyone, I'm Sarlan Nimuenanyo from BSCS CS3M1, presenting my midterm final activity. I will be going to present about bubble sort, heap sort, selection sort, and greedy algorithm. So first thing is, what is bubble sorting? A bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. So bubble sort is divided into 3 passes, which is first pass, second pass, and third pass. As we proceed to first pass, we will going to compare the first value and the second value. Since 5 is greater than 1, then swap. The result will be 1, 5, 4, 2, and 8. Since 5 is greater than 4, then swap. The result will be 1, 4, 5, 2, and 8. Since 5 is greater than 2, then again it will be swap. The result will be 1, 4, 2, 5, and 8. Now, 5 is less than 8, then does not swap them. Since these elements are already in order, we will going to proceed in the second pass. In the second pass, 5 and 8 is in the right position. Then, it will be our sorted array, while 1, 4, and 2 is the unsorted array. Then, 1 is less than 4, then it will remain its position, while 4 is greater than 2. Then, swap. The result will be 1, 2, 4, 5, and 8. Now, the array is already sorted, but our algorithm does not know if it is completed. Then, we will going to consider one other pass, which is the third pass. Here in the third pass, we will going to do checking. Since, as we noticed, it is already sorted, then the process is finished. Proceeding to the selection sort. A selection sort is a sorting algorithm that selects the smallest element from an unsorted list in each iteration and places that element at the beginning of the unsorted list. So here's an example of selection sort. As mentioned earlier, the smallest element from an unsorted list in each iteration and places that element at the beginning of the unsorted list. Here we can notice that 8 is the smallest value and 40 is the largest value. Then we will going to put 8 in the first position since it is the smallest value. But then, as we can see, 29 is a large number. As we scan the array sequentially, 12 is the second smallest value. Then 29 and 12 will be swapped. Since it is swapped, we're going to proceed on the third smallest value, which is 17. Since 25 is greater than 17, then it will be swapped. Here we can see that 17 is already in its right position. Then this side is our sorted array, while this side is our unsorted array. 25 is the smallest value. Then it will going to swap in 29. 32, 29, and 40 has been left because it is unsorted, while 8, 12, 17, and 25 is our sorted array. As we scanned it, we're going to notice that 29 is the smallest value. Then 32 and 29 will be swapped. The result will be 8, 12, 17, 25, 29, 32, and 40. Now we will go to proceed on our checking. Since 8 is less than 12, 12 is less than 17, 17 is less than 25, 25 is less than 29, 29 is less than 32, and 32 is less than Then, the process will be end here. Proceeding to greedy algorithm. A greedy algorithm is an algorithm that always takes the best immediate or local solution while finding an answer. Greedy algorithm finds the overall or globally optimal solution for some optimization problems, but may find less than optimal solution for some instances of other problems. Here we can see a graph. 20 is the root, which is considered as the mother, and 2 and 3 will be its child. So 3 is the only child with a weighted value of 1. Then it gives us the final result, which is 24. 20 plus 3 plus 1 is 24. But therefore, there is another path that carries more weight, which rely on the right side. It is 20 plus 2 plus 10 equals to 32. As mentioned earlier, in greedy algorithm, it always takes the best immediate or local solution in finding the answer. Proceeding to heap algorithm. A heap algorithm is a special tree-based data structure in which the tree is complete binary tree. Generally, heaps can be of two types, which is max heap and min heap. In max heap, the key present at the root node must be greatest among the key present at all of its children. The same property must be recursively true for all subtrees in that binary tree. While in min heap, the key present on the root node must be minimum among the keys present at all of its children. The same property must be recursively true for all subtrees in that binary tree. Here is an example of heap sorting. In the given array, it shows that our array is 32, 4, 2, 9, and 10. Just like greedy algorithm sorting, we will going to make a graph based on the array. Since 32 is in the first position, then it will be on the top. 4 will be on the right, 2 will be on the left, 9 will be below on the 4, then 10 will be placed below 4. Since 32 is the greatest among 4 and 2, then it will remain its position. Immediately, it will be deleted on the array because it is a maxed heap. This is the list. The list will be 9, 10, 2, 4, and 32. Since 32 is deleted in the array, 9 will move on the top, 10 on the right, 2 on the left, and 4 below 10. Since 9 is less than 10, then it will be swapped. 10 will be placed on the top, then again it will be deleted. When it's deleted, then it will proceed on the list. 10 and 32 is already a sorted array. Then 9, 4, and 2 will be our unsorted array. Since 9, 4, and 2 has been left, 9 will be placed on the top. Since 9 is a max heap, then it will be deleted in the array. The sorted array will be 9, 10, and 32, while the unsorted will be 4 and 2. Since 4 and 2 has been left, then 2 will be on the top. But then again, 2 is less than 4, so it will be swapped. 4 will be put on the sorted array. Then 2 will be deleted on the process. The final answer will be 2, 4, 9, 10, and 32.